Okay, now let's see. Here it says D is the region bounded by y is equal to the root of x and y is equal to x3. Okay, D is the region bounded by y is equal to the root of x and y is equal to x3. Now this is what we do. Remember, we've been given D. Now the onus is on us to find the limits using these conditions, right, or boundaries. He says that D is the region between y is equal to root of x and y is equal to y to the power. So first we draw, we sketch our region. Now y is equal to root of x goes like that. We've seen this before, right, in coordinate system. And y is equal to x to the power 3 goes like this. This is y is equal to root of x and y is equal to x to the power 3. Okay, so here this is our region. Okay. Now, once we see our region, we can see that the lines are meeting at 2 points. At this point and at that point. Quickly, we find the meeting point. To find the meeting point, that's if two lines meet. Then it means the value of y here and y there are the same, right? So we equate the lines. So I'm going to order curves. I'm going to equate x to the power 3 to root of x. I want to get rid of the square root of x because it's complicated, right? So I square both sides to get x to the power 6 is equal to x. Next, I bring the other one to the right hand side. I get x to the power 6 minus x is equal to 0. Next, I factorize x out. I get x out, x to the power 5 minus 1 is equal to 0. If two numbers multiply to get 0, either one is 0 or the other is 0. So it means either x is equal to 0 or x5 minus 1 is equal to 0. And here it implies that x is equal to 1. So it means that x is equal to 1, 0 or x is equal to 1. Now if x is equal to 0, when I put 0 in any of this equation, I'll get y should also be what? 0. So it means they meet at the point 0, 0. And when x is 1, when I put 1 in place of any of the functions there, I'll get y to be 1. So we meet at the point 0, 0 and 1, 1. Right? So it means that this here is 1 and that 2 is what? It's 1. Nice one. Nice one. Okay. Now with the permission, I will clean this. I know you can pause it and go over. So I'll clean this because I need the space time. Okay. Now we are about to find our boundaries. Now, let's say first we want to do this ui dx, right? If we want to do this first with respect to y, then with respect to x. This is it. Now, what's the trick? Y axis always go up and x goes sideways or horizontal, right? Now, if I want to first integrate with respect to x, I go to my region. This is my region of integration. We can all see, right? And I'm going to slice the region in the right direction. Simply put, because it's y, I'm going to slice it up. Now, if I were slicing this up, like I'm sharing it for people to eat, small sliders, they are children. So small sliders. You can see that every slide that I make, right, I move from this lower line to that upper line, upper curve, right? In every slide I make, I'm moving from this lower curve to that upper curve. So it means that this one here is my lower limit, and my upper limit is the square root of x. Is that easy? Right. Now, next, we want the limit for x. The limit for x are actually the two lines that in the x, on the x axis, not in the x axis, the 2 points, or the interval on the x axis that holds my region in place. And those 2 points, or the interval, may or may not be part of my region. So if I look at this, the interval on the x axis that holds my region in place is here, 0 and 1. So I put it here. It's that simple. You can see. Next, let's look at that of y. If I want to first integrate this with respect to x before y, how to find your limit? And with your permission, I would redraw the diagram. Okay. Now, because I want to first integrate with respect to x, whatever I'm putting here must be functions of what? Of y. So quickly, I make x the subject in the two equations. So this is equivalent to saying x is equal to y 1/10. And this is equivalent to saying x is equal to y squared. I hope you follow. Just making as a subject, right? Now, good. This is my region. If I want to integrate first with respect to x before y, then I must first slice in the x direction. And in slicing, I slice like that. Now in slicing, I can see I'm moving from this to that. So this is my lower. So my lower is actually y squared. And my upper, which is this, is y 1/10. Remember, here was 1 and here was 1. Now, if I look at two intervals on the y-axis, that hold my region in place. It's 0 and 1. It is that simple. Okay. Okay. So I'll take another example. And we will choose. So here, I first did it with respect to y, then x, before x and y. Okay. Let's look at D and here we say D is the region bounded by is the region bounded by y is equal to x squared, y is equal to 0, and x is equal to 2. Is the region bounded by this, right? Okay. First, we sketch the region. Y is equal to x squared, go like that. And y is equal to 0 is the x axis. And x is equal to 2. If here is 2, it goes up, right? Okay. Now, if this is 2, which is part of our region, if this is 2, then we'll cut here at 4. Because when I put 2 in place of x here, I'll get 4. Okay, so here, this is my region. You cannot see this is my region, right? Okay, so let me clean this part. I don't really actually need this part. Okay. If this is my region, right? Then let's try and integrate this first with respect to y, then x, right? Remember, the curve here is y is equal to x squared, and this line is x equal to 2, and this is equal to 0. You can see. Now, if I'm to integrate this dy dx, right? Then I'm going to slice in the y direction, and in slicing this in the y direction, I move from this up. So every slice I make, I move from y is equal to 0 to the curve y is equal to x squared. So here is 0 and x squared, right? And the two lines holding it in place in the on the x-axis, or the interval on the x-axis, from this is going to be 0 and 2. Okay. Now let's see. Let me draw this again. Now, if I want to do this dx dy, then I must make y x the subject. If y is equal to x squared, and it's going to x is equal to the square root of y. Here I slice in the x direction because it's s first, right? And in slicing, I'll move from the curve to the line to this line, which is s equal to 2. I move from the curve, which is the root of y, to x is equal to 2. And the the interval on the y-axis that holds my region in place will be from 0 to 4. Okay. I hope you got that one. Good. As I said, our main aim is not how to integrate that. The integration was done, or in most of the questions in the book, the integration has been done systematically, right? The idea is to how to find the limit. But if you at least, if you find the limit and you can't integrate, then it means that you've done, I won't say it's less job, but just part of the job. So learn how to integrate so that you can do the integration yourself, right? Good.